Okay, I'd like to go through a proof of the quotient rule. Remember that the quotient rule says that if we have the derivative of f divided by g, that this derivative is equal to the bottom function times the derivative of the top minus the top function times the derivative of the bottom all over the bottom function squared. So let's suppose f and g are differentiable on some interval. And let's look at the limit definition then. So we have the limit as h approaches 0 of f of x plus h divided by g of x plus h minus f of x all over g of x all divided by h. So this is the limit definition of the derivative tailored for the quotient function. So as a trick we've seen before, what I'd like to do is clear out the denominators by multiplying both the numerator and the denominator by g of x plus h times g of x all over g of x plus h times g of x. So right now we're operating on the assumption, I guess, that these two aren't going to be 0 when we're finished evaluating the limit. So if we clean things up, we get the limit as h approaches 0 of f of x plus h times g of x. Let me go ahead and color code that. Times g of x minus f of x times g of x plus h all divided by h times g of x plus h times g of x. So this is equal to the limit as h approaches 0. So now we're going to try a trick similar to the one we used with the product rule. We're trying to build some derivatives inside of this expression. So what I'd like to do is I'd like to both subtract the term f of x g of x and add the term f of x g of x. Okay. So the next step is going to be a little bit tricky. What I'd like to do here is let's go ahead and first rewrite this limit as the limit as h approaches 0 of 1 over g of x plus h times g of x. So I'm factoring this expression right here out of the fraction, and that'll leave me with times, and then I'm going to go ahead and distribute the limit over the product of the remainder. So this will give me with f of x plus h g of x minus, clean that up, minus f of x g of x plus f of x times g of x minus f of x times g of x plus h all over h. So again, what I did in this step is I pulled out this this expression from the fraction. This is similar to if I had a times b over c times d. I could rewrite that as 1 over d times ab over c. And that's essentially what I've done here, as well as distributing the limit. So we can go ahead and evaluate this limit right here. Why? Well, we said that g of x was differentiable, and remember that differentiability also implies continuity. So I can go ahead, because this function is continuous, 1 over g of x, provided g of x isn't 0, I can go ahead and evaluate this limit through direct substitution. So that was for this piece right here. Let's go ahead and give that a color. This piece right here. Okay. So now what I'd like to do is over here I'm going to start building a couple of derivatives. So let's go ahead and write this as the limit as h approaches 0 of f of x plus h times g of x minus f of x g of x all over h plus the limit as h approaches 0 of f of x times g of x minus f of x g of x plus h all over h. I guess I need to put all of this in a bracket. So this gives us 1 over, notice that this would be 1 over g of x. This would simplify, this expression right here would simplify to g of x. Being multiplied to another factor of g of x would give me g of x squared. In my numerator of this fraction right here, notice that I can factor out a g of x from both these expressions. That g of x does not depend on h, so I can pull it all the way out of that limit. So that leaves me with this. Okay. Now, likewise over here, I have these two factors of f of x. Notice that they depend upon x, not the limiting value h, so I can factor that out of that limit. So I'll go ahead and pull that out. Additionally, I'd like to pull out a negative sign. So this would let me rewrite this limit as, so if I factored out this negative, this expression would be positive, so that's g of x plus h minus g of x all over h. So now all we need to recognize is that this expression right here is the limit definition of f prime of x, so we can replace that with f prime of x, that's times, minus f of x, and then this limit expression right here is g prime of x, so we can place all of that with g prime of x. Sort of cleaning up our mess then, we end up with g of x times f prime of x minus f of x times g prime of x all over g of x quantity squared. So again, we assume that f and g of x were differentiable, and we were able to show that the derivative of the quotient of f divided by g of x is given by the quotient rule here.